SIMATIC IDENT is our sort of brand name for industrial identification products. Primarily for us, that contains three sort of product areas. The reason that we have this area is because obviously, as we all know, you can't have sort of control without the knowledge of what you're controlling. And as we move forward into the sort of the current age of, or future age of production, we need more and more information about what's coming through our production lines, what's coming through our logistics warehouses, that sort of thing. As I say, why do we need it? Small batch sizes, increasing complexity, the speed, agility of your businesses all need to be increased in this day and age, especially with sort of the economic climates at the moment, having to change over products, having to change over components and things like that due to supply, all that sort of thing. It's all sort of essential to keeping your business flowing correctly, moving forward into industry sort of 4.0. And as we all know, if you stand still, you get left behind. So unfortunately, it's one of those things that you kind of can't do without going forwards. Not necessarily from Siemens. I'm not saying you have to come to Siemens to move forward into industry 4.0, but we do certainly have a compelling offering, I like to think, at least anyway. So how do we identify? As I said, we've got RFID, radio frequency identification, OID, optical identification, and RTLS, real-time locating services. So what does each of those comprise? Well, starting with RFID, you may be familiar with RFID from things like if you've been to Decathlon recently, everything in Decathlon has an RFID tag label, and you put everything in a bin at the checkout and it just scans it all and it knows exactly what you've got. RFID in industry is used for a few different sort of applications. There's primarily three areas. There's access control, there's production sort of flow control, as you can see there in the little image on the left with the reader underneath the constrained production line, and there's logistics. So in your warehousing, in your logistics centers for scanning stuff coming, batches coming in and out, coming off lorries through portal doors, that sort of thing. Then we've got OID, optical identification. So this is using cameras and laser scanners and things like that. Typically, I mean, the easiest and most common way that you would use these, and what we're going to show today, is to scan codes, which can be 1 and 2D sort of data codes with data matrices, QR, barcodes, that sort of thing. But you can also obviously use optical identification for things like pattern recognition and do more intelligent things with assessing quality. Are we missing screws in certain places? Are PCB components fitted in the right place? That sort of thing. So that's sort of optical identification. And then we have RTLS, real-time locating services. So RTLS is our kind of new or newest technology. It's quite a new technology in the market in general, and Siemens has quite a few unique selling points when it comes to real-time locating services in terms of having hybrid systems with RFID and RTLS, as well as being able to have these what we call e-paper transponders that have this e-ink display, much like a Kindle, very low power, but actually gives you a way of interacting with the operators. And RTLS is essentially like your own indoor GPS system, your own private sort of GPS network, down to about 30 centimeters accuracy for tracking assets, tracking materials, maybe it's forklifts, maybe it's lone workers, things like that. It gives you that real-time position information to really sort of increase the efficiency of your production flow. So we'll just go into a little bit more detail about each one quickly. So like I say, what is RFID? Essentially, RFID is two components. It's a reader, which has an antenna attached to it, and a tag. Typically, when we talk about RFID these days, it's passive RFID. That means there's no batteries in the tag itself. And the tag is essentially just an antenna attached to a little chip. Some tags actually don't even have a chip. They are just an antenna that's arranged in such a way that they can communicate a serial number. Some tags are just a serial number. Some also have user data areas, depending on what you're going to use them for. And then there's also a bunch of form factors and things like that as well. In terms of types of RFID, we've got a couple of examples here from our range. High frequency is typically used for the line side RFID, shorter range, higher data, particularly with the RF300 that you can see here. We have a class-leading data speed and data volume for RFID, which is used on many engine production plants, for example, across the world to write batch data actually to the transponder attached to the engine block. RF200, similar sort of applications, but with a bit of a different scalable range for different applications like IO link or inside CNC machines where you need a really small reader. RF1000 is our user access control reader. That actually can also do low frequency because low frequency is used in user access badges sometimes. And then we have the ultra high frequency band on the right hand side, which is primarily our RF600 range, and that's our logistics style reader. I was talking about kind of the differences between the types of RFID and the types of readers. Just very sort of roughly, there's an idea. So the range along the bottom, you can assume that the x-axis is sort of like the frequency. So the higher in general the frequency, the longer range you can achieve. But typically you'll be looking at lower storage capacity applications, whereas with, like say, the RF300, you could be writing quite a lot of data to tags. Quickly looking further at the RF200, that's a quick look at the range. So you've got readers and antennas, there's a load of transponders, a handheld, and then communications modules to pull it onto any bus system that you please. We also have an IO link version of the RF200 range. All sorts of different sizes and shapes of reader. You can see here, this is an example used in tool change applications. So the tool on the right there's a little proximity switch style RFID reader and actually RFID tag embedded in the CNC machines tool there. So you can have sort of dynamic storage options and things like that, increase the efficiency, avoid having the wrong tool selected if it was put in the wrong place, that sort of thing. Then we've got the RF300. Similar again, readers, antennas, transponders, communications modules. The one difference is that we've got this RF300 protocol for our, like I say, class leading in terms of data volume and data transfer speed for certain applications. And as an example here, we've got vehicle transmission manufacture in a car factory, like I say, underneath the conveyor belts, as you can see on the right there, well, not conveyor belts, but roller conveyors there. Used a lot in the automotive industry, but all over the place, to be honest. It's a very popular range. RF600, like I say, this is our ultra high frequency reader, which is growing in popularity now due to the fall in cost for ultra high frequency devices, transponders and readers over the last sort of 10 years or so. The increased range is the primary reason for its popularity because it does mean you can start applying it to those logistics applications. Again, you can see we've got readers, antennas, there's a handheld and a whole range of transponders as well. These can be configured in all sorts of different ways because you can have up to 4 antennas connected to one reader for these devices. So you could have 4 antennas around a loading bay door, for example. You can see on the top right there, we've got some antennas either side of a forklift door, scanning car body parts, scanning tote bins going around a production line. Loads of different applications. That one's a box sorting facility. It's essentially if you need more logistics style RFID, higher range, higher tag volume, but not actually sort of reading and writing data as much. That's where the RF600 comes in. RF1000, I won't talk about too much because you're going to see it a little bit later anyway. That's our user access control badge reader, as we described previously. USB by default, but it can also be had with RS232 if you want to connect it directly to a PLC or something. The USB is designed to integrate directly with our comfort panels currently, and hopefully as of version 18 we should have it integrated into WinCC unified panels as well. We haven't had that 100% confirmed yet, but it is 100% planned for integration in version 18. So we'll have that very shortly with unified as well. It can also be integrated into WinCC runtimes, WinCC SCADA, of course, that sort of thing. And it does link with PM logon, which is part of the PM packages for SCADA systems. So if you need to do things like audit trails for pharmaceutical sites and things like that, this reader can be part of that system for a fully end-to-end encrypted user logon system. You can see there the PM logon. PM logon basic is what you'll see on the HMI panels with the free little optional HMI option plus pack that's being demonstrated later. What is it? I think we've already kind of explained that. Apologies if I'm going quickly. I'm just conscious of time. I don't want to spend too long on this, so we can get on to the demos. 1 and 2D code types. There's obviously lots of different application methods for that, as well as printed, laser etched, drilled, embossed, that sort of thing. All of that is entirely possible. This is the sort of range we've got. Historically, for the last 15 years, we've had the MV400 range, which was the 420 and the 440. About 3 or 4 years ago now, we had the release of the first MV500 camera, which is now sort of fully featured, and we've just had the release of the 530S, which is the new entry-level, all-in-one camera for sort of more simplistic, purely code reading applications where you don't want to have to specify a lens. It just all comes in one package. This is the reading range. There you go. We do also have hand laser scanners as well on the left-hand side there, if required. That again can be integrated with WinCC. As a closer look up there at the MV500, a bunch of different highlights. Liquid lens option is definitely a highlight on there, so that you can do autofocus without having a sort of mechanical motor moving part. It's a liquid packet instead that changes shape dependent on the electrical signal provided. There's loads of accessories for these, so obviously lenses, lights, different cable connection methods. And as an example here, perfect example of where you might use one of these cameras, you're reading barcodes on the side of a product to ensure that those barcodes are legible. If that's going out to something like a supermarket and you've sent out thousands of products and suddenly you get a call back saying, hang on, we can't read any of your barcodes, we can't sell your product without being able to read your barcode, that's a massive problem. So using cameras is a great way of assessing the quality of codes. You can even dynamically adjust printers and things like that. Also used for things like robot coordinates. We actually have this in our demonstration centre in Manchester, which some of you may well have seen before, where we're using the camera to identify an object and then pass through the coordinates of that object into the motion system to go and pick up a load of ping pong balls in our case. Then we've got RTLS. So as I said, RTLS is essentially your own private GPS system. You have gateways that sit in the ceiling, typically hung down from the ceiling. Those are like your satellites. And then you have transponders, which in this case, in comparison to RFID, these are battery powered. And these behave much like your car's sat nav or something like that, essentially sending out a ping. All the gateways receive that ping at different times. They all have a time synchronization across them, so they can work out based on the time of flight and when each one heard it. They can triangulate the position in real time. That's sort of what a typical network layout might look like. These RTLS systems are they do tend to be a larger project, and they sort of innately come with a network system as well as an IPC or something for the actual software and databases to sit on. And the idea with RTLS is that it's kind of a engineering backbone product initially. You can then connect that up to your own business logic. So if you have your own business logic systems like Oracle or SAP or something like that that you want to feed the data into, that's what it's there for. That's entirely possible. But if you don't have any of that and you just like a sort of visualization system out of the box, sort of, we also have location intelligence, which is an edge application that's available for purchase, and that does give you sort of more the heat maps and sort of process flow sort of information. And that's an idea of what the products in that portfolio look like. I've put the RF600 in there as well, because like I say, you can actually do a hybrid system with RFID as well as RTLS. And here's a use case. This is our factory in Firth. They produce a load of, sorry, actually that picture isn't, but our primarily use case from one of our own factories is a factory in Firth where we produce PCBs. Those are stored in black tote bins. The tote bins all have an RTLS transponder on them, and because we know where they all are in real time, they can have a completely dynamic storage system. So you don't have to have any dedicated space. The AGV can just turn up at an operator station when there's a batch ready. They plonk it on, the AGV goes and pops it down wherever it needs to, because it knows where the spaces are, it knows where it needs that product to be next. It's sort of the data transparency is what we're talking about here, that really enables businesses to be more agile and flexible with their production. I do have a little camera feed here, so you can see my hand there. So you can see the actual physical setup that I've got. So I have the MV530 here. I'll just make that bigger for you for the moment. MV530 here on a little arm. This is connected to power and a Profinet cable. Profinet cable coming into our switch. Our switch is also connected to my laptop and this 1500. You can ignore that I/O rack for the time being, that's not plugged in. And all we're going to be reading for this moment is the data matrix code on the side of another camera, just for the purposes of this demo. So we'll kind of just go straight into it and see how quickly we can do this. The first thing I'm going to do, by all means, stop me if anybody has any questions, by the way, just jump in. Otherwise, I will just ramble off into infinity as fast as I can. Just going to drop in an unspecified CPU to start with. So for those of you who may not be familiar with this process, an unspecified CPU, you're roughly telling TIA Portal what it's looking for. And then if we hit detect, it will actually go and look for valid devices on the network. So there we can see it's picked up our PLC already. The PLC already had an IP address, but it doesn't have a program in it. So it's detected that IP address. So I just hit detect there and it'll pull in the exact correct device with its existing network configuration. So back in devices and networks, I'll just zoom this in a little bit for you so you can see a bit closer. If we go into network components, if we go into detecting and monitoring, ident systems and optical identification systems, and then we've got the MV500 down there. This folder, by the way, is just installed by default. So we always talk about the power of TIA. This really is the power of TIA. There's no GSD files or anything like that. All of the data is natively in TIA Portal, which comes with all the benefits of the diagnostics and ease of setup that we always talk about. So we dropped an MV500 in there. I connected it up to my PLC just by dragging and dropping. And the only other thing I'm going to do in the properties, you can see here that it's already been given the next IP address on the range. The only other thing I'm going to change is the operating mode. Just set that to ident profile, because that'll allow us to use a technology object for our command handling. I'll just assign the Profinet device name now to the camera. If I've got ProNetter open here, you can see that the camera has no IP and no subnet by default. This is a factory default. You could set that in here and manually access the camera that way if you wanted to, but we're going to do it via TIA Portal. So I'm just going to assign the Profinet device name. Profinet is a name-based communication, so it actually uses the Profinet device name as the primary method of communication. So if we assign that to the camera, when we actually download the hardware to our PLC, the PLC will then hand out the IP address to that device. So we'll just download to the PLC now as well. So all we've currently got obviously is just the hardware. I'm just doing this so that the PLC knows what it's connected to and can give the IP address to the camera. You don't have to do it in this order. Like I say, you could just assign it manually with ProNetter if you wanted to. That's just talking about different modules online and offline, because I've got a version 2.9 CPU and a 2.8 in the project at the moment. I'll just start my CPU as well. So our camera, I didn't have the camera feed up, but our camera just flashed, which tells me that it's just had its IP address set automatically by the PLC. If I come to the camera properties here, we can open the web diagnostics. So you don't have to do it that way. Like I say, you can just type in the IP address, but since we're in TIA Portal anyway, let's go through this method. So I'll click on the camera just to open it up. And the first thing I'm going to do is just go to our communication. There's all sorts of options in the web interface here. And I'm going to scroll down and just change our trigger source and our feedback source to Profinet IO before I forget, because I did that in my test setup and I couldn't work out why it wasn't working, and then realized I'd just forgotten to tell it to look at the PLC. You can obviously have these cameras connected to hardwired IO for the trigger as well as the feedback if you just want an OK or not OK, for example. But in this case, we're going to connect it to our PLC. There's loads of options in here for communications, as well as all sorts of options for on the camera itself. Security, you obviously can set up user management as well. In this case, I'm not using it. And if I open this up now, there will be a flashing image on screen, by the way, just in case anyone's sensitive. I'll just bring up the camera feed and you can see the camera started flashing away there. One difference you might notice with the MV530 is it is a green coloured LED rather than red. That's just because for the MV530, because we were coming up with a specific lens and light for this camera that are going to always be with this camera, they could do a little bit more accurate tuning of exactly what light colour was optimal, and turned out green in this case was optimal. What I'm going to do now, I'm just going to move these over to one side so that you can see both at the same time, and just zoom this out a little bit. And what we're going to do is the automatic setup process. So this is, again, one of the really powerful ease of use features of the cameras, is the sort of one button setup. Apologies, this is very small. This is just so you can sort of see what the camera is doing. There is actually a read button on the camera itself, which triggers essentially the same function. So in theory, you wouldn't actually have to access the web server at all if you wanted to set the camera up just to give you a data matrix code. But for these purposes, I'm just going to click auto setup of the full program. And you can see it's started to do some analysis there. It's already picked up that code. It started adjusting the sort of exposure settings and things like that. And there we go. And it's auto tuned for that code that we can see there. And we've got some quality values coming back straight away. I'm just going to save that as a new program for now. There's obviously a ton of other options that you can go into in the camera settings to do with the decoders, quality, the actual format of the output and things like that. In this case, the format of the output is just going to be what our code says. So for the time being, we'll forget about that now, and I'll just put the camera into run, and we'll head back to Tier Portal. So back in Tier Portal, if I open up my technology objects folder, and this is the same folder that you use for motion control, PID, counting and measurement, but we also have a SIMATIC IDENT section here. So I'm going to add a TO ident. Forgive my naming, I'm just going to leave everything at default for the in the interest of time here. And it's automatically opened up that technology object for us. And I'm just going to point it at our distributed I/O, Profinet I/O system, IID device, ident profile, just pointing it at our camera. And the only other thing I'm going to select in here, there's not many options in comparison to motion. The only other thing I'm going to select is when we send a reset to the camera, I just want it to select program 1. And that's it in the technology object. So it's if you're familiar with motion control technology objects, it's a little bit different because you have a lot more configuration in those. The purposes of that technology object really for the ident is to act as a command handling device. So we don't have to worry about sequencing or anything like that. That will deal with the command handling for us. We're then going to come into our main OB1 and put some blocks in. So down in optional packages, I always say this is a little bit silly because these blocks are installed by default, even though they're in the optional packages section. So in your Tier Portal installation that you already have, these should be installed. And the only two blocks that we're going to pull out in this case are reset reader, which allows us to reset if we have errors, as well as sort of initialize a device in the first place, and the read MV. There are other blocks as well for doing things like changing the program from the PLC program and things like that, but we're not going to use those for the moment today. I'm then just going to drop my technology object onto those blocks. So the technology object is then acting as our sort of pointer for the device that we're talking to. You can see here on the read block, we've got another pin that needs something just called ident data. So the read MV block is going to spit out an array of bytes for us. And that array of bytes is whatever we configured it to be in the camera. So by default for us, it is just going to be a the code's actual number. I'm just going to put in an array here. Let's say 0 to 255 of byte. So there we go. We've just got 256 bytes in an array there. And then if I open up my details view and click on the data block, I can drag and drop that array onto my read MV block. So it's got somewhere to put the information. We could obviously then go down the sort of rabbit hole of converting that data and splitting things up and playing around with strings and stuff. And I have done other videos on that, which are on a YouTube channel called SIMATIC IDENT How-Tos, if you're interested. But for the purposes of this demonstration, we won't go into that too much. So that is literally all that is required for now to get that code into our project. I'm just going to download the program to my PLC. Finish. And we'll go online. And I'm just going to create a watch table so that we can see the values coming in. So we want the, not in the address, we want the name. So in our reset block, we'll just get the execute of our reset block. And then for our read block, we'll get the execute of that as well. And I'll open up split screen here and let's just take the first 20 bytes of our array just so we can see some data coming in. It won't obviously mean that much to us in this instance, just because it's the sort of the raw data coming in, but I'll just go online now and open up the camera next to it so you can see a little bit more what's happening. Let's get that about there so you can see it happening. Okay, so using Control and F2, I'm just going to trigger a reset. You see that goes true, and then I set it back to false, and then we'll trigger an execute. And you can see the camera flash there, and straight away we've got data into our PLC. So in our block now, in our data block that we called data block 1, in a really sort of proper naming structure, you can see there that we've now already pulled that code value back into the PLC. And it's literally as simple as that. It's 2 blocks, 1 technology object, all of it is pre-built. It's all already into your portal for you. I believe this was integrated as of version 14. I think the technology objects first came out. So anything above that, you can start to use this sort of system. The cameras do have loads more capabilities, like I say. If we move up the range, we can start to do things like object recognition and get the coordinates into our PLC, that sort of thing. But for the purposes of this demo, that's just about all I wanted to show. So thank you very much.
So this is one I prepared earlier. As you see, it's version 16. So this does take slightly longer than 15 minutes. So I'll really quickly go through it. So this is the HMI Plus option you can download from Siemens website to give you this RFID configuration on a existing comfort panel. Although it's version 16, it will work with version 17. So hopefully our video is starting. I'm now going to assign the IP address. Can everybody see that it's changing? Everyone okay with that?
Yep, we can see that.
Let's go. Okay, I'm going to assign the IP address as 192.168.10.20. So I've downloaded the software. There's 2 bits of software regarding them. It's this one. If I just stop it there. So this is the option plus setup. This is for the comfort panel itself. Start the setup. Doesn't take long to install. Finish that. Right, I'm using ProSave to download this into the HMI. ProSave comes with WinCC, Basic and Advanced and Runtime. You can also download it separately. So we need this to download those files actually onto the HMI. So the first thing we do is general, define the device type, the connection, and the IP address. Go to options and just do device status. And she'll come back with the installed configurations ready. So we've got Internet Explorer, Media Player, and File Viewers. Click on the option plus on the left-hand side. Click the 2 arrows in the middle to transfer it onto the HMI. Now we will get an error. I've done this purposely because you will forget to do this. Okay, so we go back into the HMI itself, go to settings and transfer. There's a box we just need to untick, or an option to untick, validate signatures. So untick that, okay that, and we go back to ProSave. Go and now try and transfer HMI Plus, and hopefully this will go across. This does take a little while. In the far right hand corner, if successful, we get the transfer of the data. As you can see it now, 6%, 7%. So it does take a little while, but not long to go now. It's all done. I can now see in the right hand side now we've got the HMI option plus. Right, back in TIA, first thing I'm going to do is add the HMI. So this is a TP1200. As I said, version 16. To skip the wizard, and all we need to do, delete that annoying screen message comes out in the middle. Now we've just got to assign the IP address. So much is the same as before, 10.20. Now, as I said, I've already downloaded the HMI Plus options. And so need to go to the libraries now and install the library. So open the global library, find where you've downloaded and installed it. I've got it into global libraries, HMI Plus version 3. So these are the two files I've downloaded. We've done the setup already. Now this is the library. I'm just going to do an update to make sure everything's concurrent with our project. So the first thing to do is we're going to copy these actually from the library into our project library. That way it's easy to use, and we don't have to worry about the global libraries at all now. So as you can see on there, we're going to drag this into our project library. So this does take a little while. Really, I should have edited this beforehand. So once we add the necessary components in our project library, we need to then transfer them actually into our TA project. That's going to bring up the logon dialog. And so this button's just going to do log off. So whichever operator has been logged on, that's going to log it off. And just to see who's actually logged on using this window. Right, so now I've gone into the user administration, and on the against the administrator, I'm just going to cut and paste one of those unique IDs, and then create a user, and then associate the other unique ID from the tag to the user. Okay, again, just cut and paste. Download to the HMI. I just mentioned it because we've actually changed the passwords under the user administration. We need to overwrite all, otherwise the existing passwords will only be there. So it's important you do this. Sorry, that takes a little while. We go back to the smart client now. So I'm going to put one of the tags against the RFID reader. Log on. Hopefully she will come back and say users have been logged on. Log off. Log on and put the other RFID tag against it, and it should be administrator. Okay, log off. And just to say there's no smoke and mirrors, I've got a catch up camera. So log on. If you see in the bottom left hand corner, you've got some feedback in LED. When it goes orange, it's actually seen the RFID tag. Log off and present the other. Now we've got administrator. I've now got another pre-configured project, and this now is going to demonstrate very hopefully quickly the automatic log on and log off without having to press the log on buttons. So I've added a few things. I've got an indicator now to say the tag's been recognized, and again this will just duplicate the user who's been logged on. Also I've got a maintenance screen button, so when it's pressed, if we've got the proper authorization, it will open up the maintenance screen. So I'll assign a configuration or runtime security called configuration. This has been assigned to only the administrator. So under the user groups, administration group, obviously he's got access to everything, but the user can only do operate. He's not access to the configuration. So this is just a maintenance screen and a button to go back to the home screen. It's also going to log off automatically when you press the button to go back to the home screen. Now doing this, there are a couple of options you have to drag across. So option plus PM logon, and another script, again PM logon. The only two things you have to change to get it to automatically recognize the RFID tag and log on. Again, overwrite all because we have changed the authorizations. So I'm going to put the RFID reader or tag against the RFID reader, and the green circle should hopefully change, and should we get the user information. So there we are, user. If we remove the tag, it should automatically log off as well. So put the other tag against the reader, and it should be the administrator. Again, just to show it wasn't smoke and mirrors,